we're going to go over one thing at least. Then I'm going to see if you have any questions, and if not, I'll at least give an overview of deployment options for Java. In other words, how do you actually deliver your Java programs to the world? So let's look first I think what we're going to start off talking about is enumerations. And enumerations might be a better way to handle when there are only a small list of values that a variable can take. For example, the classic one we went into was pizzas, where we had small, medium, and large. All right? So originally we made that a string and just had an attribute. And our code was looking for, I think, S, M, and L. And if you sent something other than that to it, it didn't work. It didn't recognize it, and therefore it didn't give you an error, but it didn't calculate correctly. All right? We found a way around that to throw exceptions if it didn't get an expected value. So we could still keep it as a string, but if you gave a value that wasn't S, M, or L, you would throw an error. All right? So that's another way that you can do it. Enumerations is sort of the third way to do it, and it kind of has advantages over, well, it definitely has advantages over the first one, right? Allowing you to set an invalid value and having it break your code is not a good option, you know, but we did that early on in the semester because we didn't learn a better alternative yet. With an enumeration, you actually set up and define the list of valid values that a field could have. So let's look in the pizza class. All right. I defined in here an enumeration for pizza size. All right. And pizza size can have three values: small, medium, and large. All right. We'll go and we'll do the same thing for crust in a minute here. But now, instead of accepting a string variable for pizza size, we define the pizza size attribute as being of the type pizza size. It's almost like a class. All right? It's almost like a class. And when I say this size can only have the value pizza size, it means it has to be small, medium, or large. So I replace everywhere that I had string for pizza size with the enumeration pizza size. So the constructor for pizza accepts a pizza size, a string, and a Boolean. The other constructor accepts a pizza size and a string for crust. The set size accepts a pizza size argument. The get size returns a pizza size argument. And then when we do our comparisons, we say if the size is equal to pizza size small, pizza size medium, pizza size large. So we're in business. All right? How do we set that? And so on? Well, doesn't really come into play here. Because this simply contains an array of pizzas, but it doesn't get into the details of the pizza. There's good encapsulation here. Everything about a pizza is stored inside of the pizza. An order has a list of pizzas, but it doesn't get into the details of what's inside it. And then in the order test, instead of creating it with a string, we create it by specifying the enumeration this way. Pizza.pizzasize.large. Pizza.pizzasize.medium. And so on. So if we were to compile and run this, we'd get something like this. Crust is thin, size is large, has pepperoni false. Size is medium, has pepperoni true. Okay? Questions about this? Let's see how we can loop through. Here it shows an example of how to loop through these. So, for example, if I want to make a drop down for this, find my drop down example. Oh, let's do a radio button just as well. I wanted to create a list of radio buttons for each type, I could do something like this. So rather than having hard-coded the list of radio buttons, I could actually loop through and dynamically create as many of them as I need, depending on how many of them there are in the enumeration. Okay. So there we have our radio buttons where none of that is hard-coded. So in other words, we have not hard-coded in those three values. Those three values come from the enumeration. And what we did is we looped through all the values in that enumeration. That's essentially what this does. For pizza size, in other words, this variable s is going to be a pizza size variable. We get that from the list of values in the pizza size enumeration that's contained in pizza. All right. Each time through the loop, s is going to be the next pizza size in the list. So we create a new radio button, and we set the text of it to be this. BG add, so we add it to the button group, and we add it to the panel. So in other words, if we come around and define an extra large, and save everything, we don't even have to recompile it. We do have to recompile it. We actually only have to recompile the pizza class, though. I stand corrected. I would have to recompile it. But again, it's a small price to pay. Whoa. No, this is size. I might have been saying crust, but this is, yeah. Oh, I'm not allowed to have that dash. There we go. And now our drop-down has all 4 of them in there. And if we pick that, it tells us that we picked extra large. Now, if we we're going to do the same thing for crust, what would we do? Well, we'd define our enumeration for pizza crust. Would put in the 2 values, thick, thin. We would change this to not being of type string, but of type pizza crust. We would change the constructor to accept a pizza crust. Change the other constructor. Change the get and set. And I think that's it. We then have to change the constructor. pass the appropriate values in. And we're good to go. And it should work. Would we ever have to change the has pepperoni to an enumeration? It's already a Boolean, right? If it stayed a Boolean, then we wouldn't have to do that, right? Because the whole idea of enumeration is where we're limiting the values that a variable can be set to. And already, if your only choices for pepperoni were true and false, already by defining it a Boolean, all right? When you went and made exceptions, you didn't have to test for exceptions for the type of whether it was pepperoni or not, right? Because the compiler made sure that it was only a Boolean, true or false. Now, if they changed it to yes, no, or extra pepperoni, then there would be three choices, and yeah, you could make a enumeration for that. Now, the one thing I do want to say is in this radio button test, at this point, the text is a string. So even though it displayed the string, you would have to convert the string to the enumeration if you're going to use that to set the crust or the size of the pizza, right? It isn't truly a enumeration, so it's the name of the enumeration. So let's see, is there a way to convert string to enum? All right. Yeah, with the value of. So it's pretty simple that we could say that pizza enumeration value of pizza enumeration value. And that would take the text that was in here and convert it to an enumeration, which you'd have to do, because if I use this technique, like I used here, I'm actually getting the text. I'm not getting an enumeration. And that's important to realize if you're going to use this like in a GUI, that you would have to convert that to an enumeration for it to work. Questions about this? The good news about this is it sort of guides people on how to use your class, because those enumerations define the only legal values that they can set, as opposed to having something as a string and you check for and throw an exception. This seems to be a better way because the compiler will test it. So for example, if I try to go in and set a pizza to big instead of large, the compiler knows that that's not legal, all right, because big is not included in that enumeration. Therefore, you get the error at compile time. Remember, errors that you get at compile time are better than errors that occur at runtime. And exceptions would occur at runtime. So therefore, if you had code that set to a string, and the string was big, B-I-G, the compiler would say that's okay, because the exceptions aren't checked until the code is actually ran. All right? So the compiler would say, it's okay. That function wants a string, you gave it a string. All right? Nothing wrong with that. However, it's much, much better to catch that error at compile time via an enumeration than to allow it to go through the compile and compile correctly, but then catch it with an exception. Now, if you had a case of something like we had with course hours, all right, you can't use an enumeration for that. Remember, we had course hours, and we said a course hour couldn't be negative, and maybe you put an upper limit on it, right? Maybe you said a course's credit hours couldn't be more than 5 credit hours. In that case, you can't really, well, actually, could you define an enumeration? I suppose you could. You would make an enumeration of 1, 2, 3, 4, or 5. You could do it that way. In the case of integers, if it was something like someone's hourly wage rate, and you said it had to be between the minimum wage and, I don't know, $50 an hour or something like that, you wouldn't want to create an enumeration for that because, there is, with the decimals, it'd be a large, large number. You'd be better off testing for a range and throwing an exception in that case. That makes sense. Okay. So these are a good idea to use in cases where you have a list of potential values for something and an attribute can't be set to a value that is not one of those. Okay, any questions on that? Are you having any problems in lab that you want to ask about? What of all the stuff that you're working on, what is most confusing to you at the moment? Yes. Okay. Okay, which lab are you working on? Okay. Okay. The one thing that I think is confusing for a lot of people, with exceptions, was when we wrote a test class, a unit test class, how to do those. All right? A lot of people had questions and had problems with that. The reason is because, let's go back to an old example. Let's see what we're doing here. I don't know if I want that one. All right, let's take this one. If you're unit testing exceptions, it can be confusing. Because of this. Let's go in here. Let's look at our unit test. And I have a whole list of test cases that I'm running into. I have this one for creating a pizza. This one creating another pizza. This one creating a third pizza. This one creating a fourth pizza. This one creating an order that is pickup. This one creating an order that's delivery. So let's go and add an exception to the pizza. So I'm going to go in and add an exception to the pizza that if the argument equals an empty string, then I'm going to throw an exception. Now, in order to do that, I have to say this method throws an exception. Because if something throws an exception, it either if someone throws an exception, if it is a checked exception, which exceptions are, that means that whoever throws it has to catch it or throw it up to someone else. All right, so I put in this method that setCrust throws an exception. If I leave that off, I'm going to get an error when I compile this. All right. Why is that? Because it's an exception is thrown in here, and yet nothing handles it inside this method. So that's not acceptable. I then have to tell, hey, this function is going to throw the exception to whoever called it. Now I'm going to make the constructor also call the setCrust method. I should do that with all these properties, but I'm just going to do the setCrust for now. And same thing. This calls setCrust. setCrust throws that exception. So this either needs to handle that exception or throw it itself. And I'm not handling it in there, and I'm not throwing it, so it's going to complain on both of those. So I have to go in and say that this also throws an exception. And I have an error in the unit test. I'm just going to get rid of that because we're not talking about that. So for every one of these, it gets an error because I haven't handled and I haven't thrown the exception. Well, the unit test is where I'm going to put the try-catch, because typically the try-catch is going to be sort of in the boss process, all right, which could be the GUI or it could be the unit test. So I'm going to go and I'm going to say try catch exception E and I'm going to output the value of that exception. I did forget the parentheses. Okay, so now if everything works okay, everything runs, okay? But if I make a mistake somewhere in here, let's make a mistake right here for the very first pizza I create. So this line 11 is going to throw an exception. And it blows up and it displays the exception for that, but it goes no further. All right? So, first error it gets, it drops out. Well, that might be okay, but that doesn't help us test the rest of it, because we didn't test if we were testing for other exceptions or other things. So the way I would handle this is I would make each little operation its own test case. So I would put this in a try. This in a try. Now, the problem we're going to run into is that P1, since that is created inside a try block, it's only visible inside that try block. So we're going to get an error way down on this line. Oops. Maybe I made another mistake. Catch, try. Oh. Can't find that. Why can't it find that? It can't find that because that was defined in another try block. So if something's defined in a try block, it can be only used in a try block. So what do? One option would be to define it outside the try block. It'll probably give us a different error saying it might not have been initialized. Oh, no, it gives us an error on this. Might not have been initialized. Because if this fails, then it didn't work. The bottom line is if you do this, this is going to be a mess. All right? So here's what I suggested people do when they write test classes for this, is have each try-catch a self-contained thing. So I'm going to, this block is going to be my block to test for the pizza no crust exception. I may make this a try-catch for something else, this a try-catch. Then I would duplicate the variables and just define a different pizza 1, a different pizza 2, and so on. All right? So I would have each little try-catch a self-contained block that tested one exception and one exception only. Now, this is for when you write a unit test. What about when you're writing a GUI? When you're writing a GUI, typically on the action, you might be creating an object. That would just go around. Your try-catch would just go around that whole operation where you created the object, initialized it, and then if you found a problem, you'd put the output to a label on the page. I don't know if that helps at all, or did you have other questions about that, or? Right. Yeah, you'll define, you can define your own exception class, or you can just use the current exception class. All right, it depends how that, by creating your own exception, you can more granularly test. You can test for a specific error instead of just a general error. All right, and then you would, in the GUI, you'd have the try going around where you create the object that potentially could have that exception. And you'd have the objects throw the exceptions until you got to the GUI. And then the GUI would be the one that caught it. All right. We can look in lab if you have further questions, if you want to see if you're doing it right or something. So, okay. All right. I'm going to end here. Your lab is probably already open. I'm going to grab the files, and then I'll be upstairs.